Hi everyone. What we're going to do is we're going to look at how to get the quadratic formula from a standard form of a quadratic equation. So any standard form of quadratic that's equal to 0 looks like this. ax squared plus bx plus c equal to 0, where a, b, and c are typically real numbers. We hope they're real numbers, not imaginary, just because, well, if they were imaginary, it'd be much, much harder. Okay, so if that's true, we're going to now derive our formula from this. Now, in case you don't know what the formula is, it's solving for x using all these letters. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, everyone should have that memorized. Very cool equation. So where does that come from? Well, it's not just made up. Nothing in math is. What it actually comes from is completing the square on this equation, which seems kind of impossible, but it's definitely not. What you're going to want to do first is make the equation easier. So to make it easier, we're going to actually get rid of the a. We're going to factor that out of everything to make it easier to work with, which is kind of crazy. What you could do is you could divide everything by it, or you can factor it out. It doesn't really matter. I'm going to factor it out just for fun. So I'm going to put an a outside, and that would be an x squared on the inside, because a times x squared is ax squared. But there is no a in the bx, so it's going to be bx over a, or b over ax, because if I were to remultiply that back in, a times b over a would just be b. So if I want to take out an a where there isn't an a, I have to divide by an a in order to undo that. Same idea here for the c over a, in order to make that whole thing times a equal to the previous line. That way, again, if we were to remultiply in that a, you'd get back to the original starting value, or starting equation. That part's kind of weird, but the rest is pretty straightforward kind of after that. So now we're going to complete the square. So now we've got a equals 1 on the inside quadratic, so it's a lot easier to complete this square. So what square are we actually completing? Well, let's kind of sketch it over here. It'd be an x by x, which makes an x squared. It's not quite a square, but let's do like that. It's a little more square looking now. Okay, so now we got to think, well, what goes in these boxes over here? Well, if it was like x squared plus 4x, then you'd put 2x and 2x. So it's actually half of the b term. The only thing is, it's not b, it's b over a. So half of b over a would be, well, a half times it, which is b over 2a. So that goes in both of these boxes, b over 2a, b over 2a, but don't forget that's how many x's we have, like it was 4x, 2x, 2x, so it's b over 2ax, b over 2ax, and then we got to figure out the side lengths. Hopefully you're still with me here. It gets a little bit more complicated with the letters, but that's really all it is just algebra, because duh, we're in algebra. To get this b over 2a area, or b over 2ax area, this has to be x, because down here, this is x, this is x, this is x, this is x. So x times something is b over 2ax. Well, that's b over 2a. So we figured out our side lengths here, and now we can complete the square. What goes in this box? Well, it's b over 2a times itself, because again, the side lengths here are b over 2a. Because this is b over 2a, so is this, and that's the same as that. So it's b over 2a times b over 2a, which is b squared over 2a times itself, 4a squared. Okay, let's take a pause there and make sure it makes sense. So b over 2a times b over 2a is b times b squared over 4a squared. So what does that mean? Well, it means this is needed to complete the square. That's the missing piece we need in our formula. So we're going to take that and add it in. So a on the outside here, x squared plus b over ax. We want to add in b squared over 4a squared, but we can't just add it in. You have to also subtract it in order to keep it equal to what it was at the beginning. And then don't forget there's still a c over a, and it's all equal to 0. Wow, that looks like a lot of fun here to solve. Let's try and make it easier. So we only really want this part because those are the pieces here inside the square. Because we've got the x squared here, we've got the b over a just in 2 halves here and here, and then we've got this part with that part. So we want to get rid of everything else. Well, how do you do that? You've got to distribute the a to just those pieces to get them out of the parentheses. So, looks kind of weird, but here it is. So I'm going to keep the pieces that I want and get rid of the pieces that are not in the square by multiplying them by a. So a times negative b squared over 4a squared would cancel out 1a in the bottom, which makes it negative b squared over 4a. So that's going to go on the outside. And then very similarly, a times the c over a, well, that's kind of fun to do. That's just c. So that's just plus c. Okay, we're getting there. Believe it or not, we're actually very close to getting the formula. I know it looks kind of shocking because this is kind of a mess, but we're very, very close. We know how this square bracket thing factors. We've got the length and width over here. It's this thing times itself. So this becomes a times x plus b over 2a squared, because that's the length and width of this square. And then we're just going to kind of put the other pieces here. And again, we're very close to done. We want to just solve this for x, right? That's super easy to do, no big deal. Let's move over some pieces. So let's add the b squared over 4a, and let's subtract the c. And over to the 0, same thing, plus b squared over 4a minus c. So we get a, parentheses, or square brackets, doesn't matter, b over 2a squared equals b squared over 4a minus c. Wow, this is exciting. Let's try and make the right side a fraction, though, because it'll be a little bit easier if it's all one fraction. So I'm going to put this c over 1, get a common denominator of 4a. That'll make things easier for us later. So that's a times x plus b over 2a squared equals b squared minus 4ac, interesting, all over 4a, that common denominator. Wow, we're kind of almost getting this formula, that's kind of the whole point. We're going to get rid of the a now. This whole thing is being multiplied by a, so let's divide by it. I'm just going to multiply by 1 over a because that's the same thing. Hey, we're getting there. We're almost done. X plus b over 2a squared equals b squared minus 4ac. I'm just going to multiply the denominators here and multiply the numerators. 1 to the top doesn't change it. A to the bottom makes it 4a squared. And then we have to take a square root. We're getting there. We're almost to x. So we want to get rid of this square by doing a square root. Don't forget the plus or minus. You got to always do that when you're solving for x. And then we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac, that sounds like it's almost there, over 4a squared. Now, with a square root, it's kind of like when we have xy squared, we can call it x squared y squared. Or if it's x over y squared, you can call that x squared over y squared. It also works for square roots, because the square root is really just an exponent of 1/2. So that's square root of x over square root of y. So because it's really just x over y to the 1/2. So x to the 1/2, y to the 1/2. It's all just basically exponent rules, is why we can do the next step here. Let's get rid of all that mess. It's not really a mess, it's good math. So we're going to do a square root of the top and bottom over here. So plus or minus the square root of b squared minus 4ac divided by the square root of 4a squared, plus or minus technically there, x plus b over 2a. Now, if we have a plus or minus in the top and bottom, you don't really need both because the plus or minus is already taken care of. So we actually don't need the plus or minus in both because you're already saying either the positive or negative version of what we have. So making it positive or negative again, it just gives you the same things in the opposite order. Now, the square root of 4a squared, that simplifies because the square root of 4a squared is the square root of 4 times the square root of a squared, which is 2a. Hey, that's pretty nice. And now we're getting really close to getting this formula done. So now we get x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. But now we just have one more step. We're finally to the last step to get x by itself. Just simply subtract that b over 2a from both sides, and then we've got it. X equals negative b over 2a. Sure, put that first. Doesn't make a difference. Good old commutative property of addition. If we're adding, we can add that in front or at the end. And then if you want to clean it up into one big fraction, the common denominator, you can certainly do that. Negative b plus or minus the square root of b squared minus 4ac all over that common denominator of 2a. And now we're happy because we're done. Good work. We got through the whole thing. That's where the formula comes from. So, short method here is, the short of this is, why do all this work every time? If this works for any a, b, and c, why not just use this really cool formula? Because it works for any quadratic, no matter if it's factorable or not. Just plug in your a, your b, and your c values. Once you've got it equal to 0, that's key, because it's equal to 0 here, then you've got your answers for what x is, your two options. The plus or minus forces you to